What's up everyone, it's Mr. Lang, and in this video I'm going to be teaching you how to simplify radical expressions. So grab a sheet of paper and your pencil and let's get going here. Before we get to the problems, you just want to stop and make sure that you know how to simplify a single radical like below. If you miss class or maybe you need a refresher, you can go back to the all videos section of the website, or you can get the notes from a friend, or you can come see me. But either way, you got to be able to do something like this to simplify or put in simplest radical form square root of 48. If you're good to go, then what we're going to do is do 6 example problems, and I'm going to go kind of quickly. So you might need to pause or go back or rewatch some things. Alright, so here we go. First question. What we want to do is simplify 3 plus radical 18. And really what I do is I look at, okay, the 3 we're good to go, but the radical 18 we need to simplify. So usually over on the side of my paper I'm going to simplify the radical 18. So I'm going to go like this. And remember, to do our simplifying, we need to put our perfect squares up in the, I usually do it in the upper right corner of my paper. To generate my perfect squares, 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared is 25, we got 36, 49, 64, 81, and 10 squared is 100. Now, I probably didn't need all these. Probably didn't need most of these, but it's always good to just go up to 10. If you need more, you can do more. Well, anyway, square root of 18 we can simplify. Remember, we want to find the biggest perfect square that goes into 18. Can't be 25, that's too big. It's not 16. 9 does go into 18 twice though. So I'm going to break this into its radical. The perfect square, 9 times 2 gives me 18. Then I'm going to break them apart. It's the square root of 9 times the square root of 2. And the perfect square one is the one that gets simplified. The square root of 9 is 3. The square root of 2 is, we're just going to leave the square root of 2. So if we go back over here, what we got is 3 plus 3 square roots of 2. And this is going to be our final answer because 3 and 3 square roots of 2 cannot be combined. It's kind of like 3 and a 3x. You couldn't combine 3 and 3x. So, I'll even just write that. If you did 3 plus 3x, you couldn't simplify that anymore. So it's the same thing with this. 3 plus 3 square roots of 2. Not like terms. There's your final answer. Alright, next question. I've already written my perfect squares up here so I don't have to keep writing them for every problem. Just kind of like you only have to write them once on your sheet of paper. Alright, so this is a fraction. We got 4 minus square root of 44 all over 2. So again, the integers we can just leave, but the square root of 44 we got to simplify. Well, the biggest perfect square that goes into 44 can't be 49. 36 doesn't divide into it, neither does 25. 16 doesn't, you can check that out. 9 does not either, but 4 does. So 4 times 11 is going to give us 44. Then I'm going to break it apart. So it's going to be the square root of 4 times the square root of 11. And the square root of 4 is 2. So it's going to be 2 square roots of 11 to simplify the square root of 44. So I'm going to rewrite the original. It's going to be 4 minus, instead of the square root of 44, it's going to be 2 square roots of 11 all over 2. Alright, so I look at this and we're in good shape except for the fact that this 2 goes into 4, and it also goes into the 2. So what I'm going to do is factor out the top. And the greatest common factor between 4 and 2 square roots of 11 is a 2. So if I factor out a 2, that would leave me with, well, 2 times 2 gives me 4, minus 2 times what gives me square root of 11, 2 square roots of 11. It would be just a single square root of 11. So all I did was factor out a GCF on top of 2, and everything else stayed the same. Now we can simplify this one more time. So I can cancel out a 2 and a 2 here, leaving me with a 1 and a 1, but we don't even write those ones because when you divide by 1 it just stays the same. So what we're left with is just 2 minus square root of 11. So if you've got a fraction, always see if on the numerator, the top, you can factor out a GCF first, and then you can cancel factors. Alright, number 3. 2 plus square root of 75 over 2. Again, I'm going to simplify square root of 75. And the biggest perfect square that goes into 75 is going to be 25, because 25 times 3 equals 75. So I'll do 25 times 3. Break them apart. And finally, the square root of 25 is 5. So we got 5 square roots of 3. So I'm going to rewrite my original here with my simplified radical. And this is all over 2. Alright, so this is similar to what we did before, but there is no GCF between 2 and 5 square roots of 3. It just doesn't work out evenly. So when we can't factor out a GCF, even when we have a fraction like this, we just leave it. So that's our answer, 2 plus 5 square roots of 3, all divided by 2. Alright, question number 4. We have 9 plus or minus square root of 50. Alright, this plus or minus is shorthand, and we'll go through what this means in a second, but we're going to do the same thing that we've done before. I'm going to simplify the square root of 50. And this is another one where 25 is the biggest perfect square that goes into it. 25 times 2 will give us 50. Separate them out. And then evaluate my perfect square here. The square root of 25 is 5. So what we got here is 9 plus or minus this 5 square roots of 2. And there's nothing to factor out here, nothing to divide, so really this is our answer. But what does this actually mean? This actually means two things. It means we've got two different answers. We've got 9 plus 5 square roots of 2 and 9 minus 5 square roots of 2. But which one's easier to write? Is it easier to write just plus or minus like that in one symbol, or rewrite this whole thing twice? They mean the same thing, but this is much easier to write, and this is the way you're going to see it. So this is kind of our shorthand. So you don't have to do all this, but that's what it means. All right, number 5. We've got 8 plus or minus the square root of 100 divided by 3. All right, well, the square root of 100 is really easy. It is one of our perfect squares. Remember, if the number is a perfect square, then there's really no work to do. The square root of 100 is 10. Okay, so I'm going to rewrite this. It's going to be 8 plus or minus 10 over 3. So in this case, we actually do want to break this up into its two parts. It's going to be 8 plus 10 over 3 and 8 minus 10 over 3. And we're going to evaluate each of these. Well, 8 plus 10 is 18 divided by 3, and we know that's 6, so that's one of our answers. And 8 minus 10 is negative 2 over 3. So we've got two answers for this. It's going to be 6 and negative 2/3. And this is only going to happen when you have a perfect square as your radical. Alright, last example. Got 10 plus or minus 2 radical 28 all over 2. So I'm going to evaluate 2 radical 28. Well, the biggest perfect square that goes into 28, not 25, not 16, not 9, but 4 does. So remember to keep that 2 out front, but then we're going to do 4 times 7 will give us 28. I'm going to separate this out. So it's going to be 2 times radical 4 times radical 7. Remember, radical 4 is 2. So we've got 2 times radical 7. And 2 times 2 is 4. So what we have here is 10 plus or minus 4 radical 7 all over 2. And we got a fraction, so we're going to look at the numerator and say, is there a GCF between 10 and 4 radical 7? And there is. Again, in this case, it is a 2. So I'm going to factor the top by pulling out the GCF of 2. 2 times what gives me 10? Well, that's 5. I got a plus or minus. 2 times what gives me 4 radical 7? That would be 2 radical 7. And this is all over 2. Now I can cancel out this 2 and this 2. So my final answer is 5 plus or minus 2 radical 7. And we can't do any more with that. Alright, so that was 6 quick problems. Let's get to the SIA questions. 5 SIA questions for you. What you want to do is simplify, put them in simplest radical form. Good luck.